So we are going to, they're at the back. We're going to continue talking about polynomials like we said. Yesterday we talked about the end behavior of polynomials. Today we're going to find the solutions to polynomials. A lot of it is just factoring, right? Lots and lots of factoring. So it's going to feel very familiar. It should be very similar to what we've done before. It's just slightly different. So we're going to do a quick factoring review here before we get started, okay? So these are the four main types of factoring. First, we'll start with the difference of squares. If you look at this first example, are 25 and 9 special numbers? Are those special numbers? What are those called, 25 and 9? They're perfect squares, right? Why is 25 a perfect square? Because 5 squared is 25, right? And why is 9 a perfect square? Because 3 squared is 9, right? So remember this, when there's a subtraction sign in the middle, that means you can do one positive, one negative. What we said 5 squared is 25, or that you can take the square root of it and you'll get 5. So this will be 5x and 5x. What is the difference of squares? And then I'll do plus and minus what number? 3, because the square root of 9 is 3. Or 3 squared is 9, right? So that's the difference of squares. Remember, it only works when there's a subtraction in between, right? This is the kind of factoring y'all are the best at. You have 3 terms, x squared, you've got a 1 in the front. So you're looking for 2 numbers that multiply together to get negative 15. Add together to get 2. Go ahead and try to find those numbers. It should be a negative or a positive 5 and a negative 3. Will give us positive 2, right? So a negative 3 and a positive 5. So when we go to factor, 1's plus 5 and 1's minus 3. What do I put here in this spot? What goes here? This is an important question that will help you later today. What do I put here? X and X. Why do I need an X and an X here? I know we are now at the point where it's just kind of habit, but why do I put an X and an X here? Because it's X squared, right? And remember, when you distribute or FOIL, the first thing you do is X times X, and that becomes this first term, right? So the reason why this is X and X is because that's X squared, okay? So just remembering that that's why we do that will help you later today. All right, let's come over here. We'll do one GCF first, and then we'll do the grouping last, because that one's the one that we probably haven't done most recently. So if you have 2 terms, you should check to see if it's a difference of 2 squares. This one is a plus, so difference of 2 squares is out. And so if it's not 4 terms, it's grouping. 3 terms might be the kind that we just did, but otherwise than that, you're just going to look for a GCF, and that's a good thing to start with any problem. So do 3 and 27 have a common factor? What's the common factor of 3 and 27? 3, so you write that in front. Are there any x's? Do we have any common x's? X squared, right? They both have an x squared, so we write that with the 3 in the front. And then remember, you write what's left in parentheses, right? So look at your first term, and when you divide that by 3x squared, you write what you have left. So what's 27 divided by 3? That's 9. Do we have any x's left since we pulled out an x squared with this first term? It's just 9, right? And then plus, and then what do I have left when I divide that by 3x squared? I just have an x left. So that's factoring out your GCF. That you should always check first. Make sure there's no GCF you can pull out first. Any questions about those 3 kinds of factoring? Those are the easy ones, just a quick review. Okay, now let's do a grouping. Remember, grouping happens when you have 4 terms, and you put your dotted line down the middle, and you're going to look for your GCF on both sides. So write down, do exactly what you just did here. On this side, look for the GCF, and then write what's left in parentheses. And on this side, look for the GCF, and write down what's left in parentheses. So go ahead and start that part on your own. Find your GCF on both sides. So on this left side, 6 and 3 have a common factor of 3. But what else can I pull out with that 3? An x squared. They both have an x squared in common. When I write down what's left in parentheses, I have a 2x for this first term, right? If I divide 6 by 3, I have 2. Pull out an x squared, I have an x left. But what am I left with here when I pull out a 3x squared? What kind of nothing, though? 0 or 1? 1, because I'm dividing. Remember, we're dividing. If you put a 0 there, it's going to mess you up, right? Because 3x squared times 0 would be 0, not 3x squared, right? You need a 1 there because you need to make sure if you multiply out, you get the same thing, right? So when we're dividing, 3x squared divided by 3x squared is 1. On the right-hand side, our greatest common factor is 2. So that leaves us with 2x plus 1 because 2 divided by 2 will be 1. Again, don't leave a 0 here, right? You're left with a 1 when you divide by 2. So then we have our matching 2x plus 1s here. That's good. So we'll pull that out as one of our factors. And then you write out what's left in your other factors. So what's left here? 3x squared plus 2. And now we have factored by grouping. This is the one that it's probably been the longest since we've done it. So any questions on how that process works again? Okay, so let's see how that applies to what we're doing today. So you guys took a quiz on polynomials, right? Looking at the end behavior. Today we're going to look at polynomial equations. So polynomials, but they have equal signs in them, right? To solve polynomial equations, it's going to be just like we did with quadratics. Whenever we set it equal to 0, we set the factors equal to 0, right? That same process. So the first step is to write the polynomial in standard form. So that's descending order and equal to 0. Then you'll factor it, and then you'll set your factors equal to 0, okay? It's just some of the factoring is a little bit different than what we've done before. That's it, okay? So it's not that different from things that we've done before. So problem number 1, is it equal to 0 yet? Nope. So always move everything over to the side where the highest degree. So what degree is this polynomial? What's the highest power? 3. So that's the degree. So move everything to that side, right? So if the degree is 3, we're going to move the 6x over there. So we'll subtract 6x. Make sure to write it in standard form or descending order, just so you don't get confused. So always highest to lowest. And if we subtract 6x over, then we'll have 0 on the other side, in the back. First thing you want to check for with these problems is a GCF. Always check for a GCF first. So do all 3 of these terms have a common factor? What do they all have in common? They all have an x in common, right? Do all 3 terms have an x? So let's pull that out first. So always check for a GCF first. Pull that out. This first term, x cubed, will become x squared when I pull out the x. Second term, x squared, will just become an x when I pull out the x. And the last term will just become a minus 6. So always check for a GCF first. Usually that will then allow you to know what to do afterwards. Because if I ignore this x, do you guys know how to factor what's left here? Does that look like the kind of thing you know how to factor? Trinomial, right? 3 terms, x squared, x number. So we look for 2 numbers to multiply together to get -6, add together to get 1, because there's an invisible 1 here, right? I'll go ahead and do the math for you this time. It should be 3 and negative 2. So this will factor into x plus 3, x minus 2. And then you just want to leave that little x out in front. Don't forget about him. Leave him out in front. And what do we do once we factor? What do we do with all these factors? Set them equal to 0, right? Same steps as all the other type of solving we've done before. We just have more factors now. So you're going to set all 3 factors equal to 0. The x plus 3, and the x minus 2. So you'll set x equal to 0, x plus 3 equal to 0, and x minus 2 equal to 0. Solving each of those, you'll end up with x equals 0, x equals negative 3, and x equals 2. So not really a whole lot different from anything we've done before. The only thing that's interesting about this is you're going to now have more than just 2 answers, right? How many answers does this one have? How many solutions does this one have? 3. A good way to check yourself, most of the time, the degree and the number of the solutions is going to be the same, right? So what was the degree of this? 3. How many answers do I have? 3. Okay, so most of the time, those will be the same. Any questions on number 1? All right, so number 2, first things first. What's the degree of number 2? What's the highest power? 3. Then make it sure it's equal to 0. So for this one, it's not equal to 0. So we're going to move these guys over to this side because you always move it to the highest degree side just to make your life easier. So we'll have x cubed plus x squared will stay on this side. We'll subtract 4x to move it over and subtract 4 to move it over. Check for a GCF first. All 4 of these terms do not have a GCF because they do not all have an x. The first 3 do, right? But the last one doesn't have an x. So no GCF here. 4 terms, what kind of factoring should I use when there's 4? Grouping, right? Put your line down the middle. And look for your GCF on both sides. So I want you to try the grouping here. You're looking for the greatest common factor on the left side and the greatest common factor on the right side. So on the left, my GCF is x squared. That'll leave me with x plus 1. Don't forget your 1. Don't put a 0 there. When you pull out an x squared here, you'll be left with an x. Here, you'll be left with a 1. And then on the right side, your greatest common factor is 4, but don't forget to pull that negative out with the 4. And that'll leave you with x plus 1 because negative 4 divided by negative 4 will be positive 1. So the x plus 1's match. So that's one of our that's one of our factors. And then what's our other factor that's left? X squared minus 4 equals 0. Once we've factored, what do we do with those factors? Set them equal to 0 and solve. This one gives us x equals negative 1. This one looks a little different, but we can keep solving it. It just has a squared. What am I going to do first to solve this equation? Not first. We got to get rid of this guy first. Add 4 to the other side first. Then what am I going to do to get rid of the square? Square root both sides. But don't forget what when you square root both sides? Plus or minus in the front. And what's the square root of 4? 2. So this will be plus or minus 2. If you're not a big fan of this solving right here, I'll show you another way you can do this one in just a second. What was the degree of this one? 3? How many answers do I have? I do have 3, right? -1, +2, and -2, right? So there are still 3 answers. Now, some of you might have looked at this step and you may have factored more because there's more factoring you could do. What is this guy right here? That's a difference of squares, right? So if you want to, instead of solving at that point, you could keep factoring. And you could factor this into x minus 2, x plus 2, right? This x squared minus 4 would factor into that. And then you would just set these 3 factors equal to 0, and you get -1, 2, and -2, right? So you don't have to go through this process right here. So if you're good at difference of squares factoring and you weren't a fan of this, then this is another option that you can do. Any questions about that one? Okay, let's do another one. Number 3, first step, what's the degree? What's the highest power here? 4. What do we do first? Make sure it's equal to what? 0, so move this stuff over to that side with the 4th power. You'll have 3y to the 4th. You'll have to subtract the 27y squared to move it over. And then you factor. This one is not a difference of squares. It has a subtraction with 27 and 3 are not perfect squares. So it's not a difference of squares, so just look for a GCF. Factor out your GCF. So I want you to try that part on your own. Factor out the GCF. So the GCF should be 3y squared. They both have 27 and 3 are both divisible by 3. They both have a y squared in common. And then you should have a y squared minus 3 left, or minus 9, sorry. 27 divided by 3 is 9. And this is one where you could have 2 options. You can go ahead and set your factors equal to 0. Or if you want to factor this one some more, this is a difference of squares, right? So that will factor some more. So factor that one some more if you want. I'll go ahead and do that this time around. But if you want to just set it equal to 0 right now, set your factors equal to 0, that's fine. You're welcome to do it that way. This time I'm going to do it the other way. So y squared minus 9 is a difference of squares. So I'm going to factor that. And now I will set it equal to 0. It's all really personal preference, which way you prefer. If you want to set this equal to 0 and solve, or if you want to factor before you set it equal to 0.
I have a question.
Yeah.
So on question 2,
yeah,
when we were like putting this square root on 4, does that include the negative? Like, does the radical go over the negative?
No, you do the plus or minus on the outside. Yeah. Otherwise, you get an imaginary number. So good question. So go ahead and solve those equations if you haven't already. So this first one, I'll divide by 3 first. And then I'll square root both sides. And I'll put my plus or minus in the front. So we'll have y is equal to plus or minus 0. But do I have to put a plus or minus in front of 0? Is positive 0 and negative 0 the same thing? Yeah, right? So you can have 0 here if you want to just put 0 if it helps you to make sure you don't forget the plus or minus, you can put the plus or minus there, right? But realize that's really one answer, right? Positive 0 and negative 0 are the same thing. And then here you'll get y equals 3 if you add 3, and here you'll get y equals negative 3. This one was degree 4, and we kind of have 3 answers, we kind of have 4, right? Because we have 1, 2 for sure, and then this is a 0, and there's a positive 0 and a negative 0, but that's the same thing, right? But what we call this is a multiplicity of 2. So 0 kind of happens twice, right? It's basically a solution twice. Right now, that doesn't really matter, but on Friday, we'll talk about what multiplicity means. And so it does match the whole degree 4 thing if you think about 0 happening twice, okay? Again, you don't have to put that plus or minus in the front, but you can. Any questions on that one? All right, we're going to do one more together. I want you to actually skip the U try here, the 4 and the 5. We're going to do 6 together, and then I'll have you do the U tries after we go through 6. So let's jump down to 6 here, and then I'll have you go back and do 4 and 5. So this problem looks a lot like, whoa. This. So first question, do you understand why it looks a lot like that one? It just has an x to the 4th instead of an x squared, right? And an x squared instead of an x, right? But it still looks a lot like our trinomials. Do you know how to factor this? Two numbers multiply together to -8, add together to, or multiply together to -9, add together to get -8, right? You're going to solve these times the same way. Okay, so first look for two numbers that multiply together to get -9 and add together to get -8. So that'll be -9 and +1. But this part is going to be a little different. You're still going to put your -9 and your +1 here. But would it make sense to only have an x and an x here? Because if I do x and x, when I multiply those together, what do I get? X squared, right? And what's at the front of this one? Is it x squared? No, it's x to the 4th, right? But how could you fix that? What could you put here instead of just x and x? X squared and x squared. So that's the only thing different about this problem is you got to do an x squared and an x squared instead of an x. And if you were to distribute this back out, now your middle terms will be x squared terms, right? And they'll combine. So that's why it works out nicely. And then you can continue from there. Option 1, this is a difference of 2 squares, so you could keep factoring that one. And then this one is not a difference of 2 squares. 1 and x squared are squares, but it's not subtraction. So you can't keep factoring this one. But you could factor this one or just set them both equal to 0. This time I'll set them both equal to 0. If you would like to factor x minus 9 first, you can do that. You'll have x plus 3, x minus 3. Go ahead and solve both of those equations. For the first one, you'll add 9, and you'll get x squared equals 9. Square root both sides. Don't forget your plus or minus. and square root of 9 is 3, so you'll get x equals plus or minus 3. If this part is hard for you, either practice it or factor that instead. This one's interesting though, because when we subtract 1 and then square root both sides, and don't forget our plus or minus, we have the square root of negative 1. What's the square root of negative 1? I. It's an imaginary number, right? The square root of negative 1 is I. So this is x is equal to plus or minus I. So this one is interesting because it does have 4 answers. The degree is 4 here. It does have 4 answers, but 2 of the solutions are imaginary. So 2 are real and 2 are imaginary. Okay? So if you want to work through the U-try problems, I will be working through them right now and put the answers so that you can check them. So this one is degree 4. First thing we'll do is subtract the 20x squared over to this side so that it equals 0. Then here we see they both have a GCF. So 5 and 20 are both divisible by 5, so that's part of our GCF. And they both have an x squared, so we'll pull that out. If we write what's left, this first term, we'll just have an x squared left. The second term will have a 4 left. And then here you have options right now. If you want to just set your factors equal to 0, you can start doing that. Or if you want to keep factoring, this is a difference of 2 squares. So this will factor like this, and then you can go ahead and set them equal to 0. Either one works. All personal preference at that point. Here I'll get x equals 2. Here I'll get x equals negative 2. Here divide by 5, and I'll get x squared equals 0. Square root both sides and put my plus or minus in front, and I'll have x equals 0. If you would like to put the plus or minus in front, you can, but that means the same thing, right? So there's really only 3 answers here. 0 just happens twice. All right, for number 5, this is degree 3. So we'll move everything over to this side where that guy is. So I'm going to move these 2 over here. I want to write them in order, so I have 9y cubed minus 18y squared first, then minus 4y, and then plus 8. So these 2 are negative because I moved them over to the other side. These 2 are positive because they were on that side, but I wrote them in descending order, the standard form. Now I'll factor. We don't have any GCF here for all 4 terms. Since there's 4 terms, we'll do our dotted line down the middle. On the left here, my GCF is 9y squared. When I factor that out, I'll be left with a y minus 2. Over here, my GCF is 4. I'm going to pull that negative out with the 4 that's in the front. And I'll have y minus 2, because 8 divided by negative 4 will be negative 2. So then my one that's the same will be one of my factors. And the other factor will be 9y squared minus 4 equals 0. And you can set both of those factors equal to 0 here. I actually recommend on this one factoring this some more, because this one is a difference of 2 squares. And I think it makes it easier on this one to factor. So we'll do 3y minus 2, 3y plus 2. You can still get to the right answer if you set them both equal to 0 at that step, but that's up to you. Set these all equal to 0. We'll have to do some solving. So this one here is just y equals 2. Here I'll have to add 2 first. And I'll get 3y equals 2, and then divide by 3, and I'll get y equals 2/3. Here I'll subtract 2 first. 3y equals negative 2, divide by 3, and we'll get y equals negative 2/3. So we do have 3 answers here. If you did decide at this point to set them both equal to 0 and you got stuck on this one, when you solve this one, you would have to divide by 9 first, and you have y squared equals 4 over 9. When you square root both sides and put your plus or minus, you have to do the square root of 4, which is 2, and the square root of 9, which is 3. And then you'll have your plus or minus. So you'll still get 2/3 or negative 2/3. So this is another option. All right, for number 7, we're going to look for two numbers that multiply together to get 4 and add together to get -5. That will be 4 and 1, -4 and -1. So when we factor this, we'll have our -4 and our -1. But remember, because this is an x to the 4th, this will have to be x squared and x squared. You can keep factoring because these are both difference of squares. So if you want to keep factoring both of those, you can. I'll do it the other way this time. We'll just go ahead and set both equal to 0. That's your second option. You'll get the same answer either way. So you'll get x squared equals 4. Square root both sides. Don't forget your plus or minus. And you'll get x equals plus or minus 2. Over here, add 1. Square root both sides. Don't forget your plus or minus. And you'll get x equals plus or minus 1. So you have 4 answers. This is degree 4. So that works out. Because +2, -2, +1, -1. Same thing here. You'll be looking for two numbers that multiply together to get 36, add together to get -13. That will be 9 and 4, -9, -4. So this will factor into x squared minus 9, x squared minus 4. And then from here, if you want to set both factors equal to 0 like we did on the previous problem, you can do that. If you want to keep factoring, I'll do it this way this time. You can keep factoring. This is a difference of squares, x minus 3, x plus 3. This is a difference of squares, x minus 2, x plus 2. And then if you set each of these equal to 0, you'll get x equals 3, x equals -3, x equals 2, and x equals -2. You'll get the same answers if you set your factors equal to 0 there, and that's totally fine. And again, this matches with the degree. The degree is 4, and we have 4 answers. 9 is an interesting problem. It's a bit of a challenge, so if you want to try it, you're welcome to try it. You do have to use some old formulas. You'll get x equals plus or minus, you'll get x equals -5, and x equals the cube root of a and x equals 0. So if you want to try that one, you can. Number 10, this is degree 3. So we'll move everything over to this side. So we'll move these guys over here. And so we'll have 3x cubed plus 2x squared minus 12x minus 8 when we move those over. This one, there is no GCF here with all 4 terms. It seemed like there might be, but there's no common term to all 4. So there's 4 terms, so we'll do our dotted line and do our factoring by grouping. Here, our only common factor is x squared. So we'll factor that out, and we'll be left with 3x plus 2. Over here, 8 and 12 are both divisible by 4. We'll pull that negative out with it. 12 divided by 4 is 3, so we'll have 3x. 8 divided by negative 8 divided by -4 is +2, which is good because these two match. So we'll have 3x plus 2, and then whatever's left, x squared minus 4. If you want to keep factoring, the x squared minus 4 is a difference of squares, so you can keep factoring. If you just want to start setting them equal to 0, you can do that. You'll get subtract 2. And you'll get 3x equals -2. Divide by 3, and you'll get x equals -2/3 as one answer. Add 4. Take the square root of both sides. Don't forget your plus or minus, and you'll get x equals plus or minus 2. So degree 3, 3 answers, and we're good to go.